Welcome back for technical session number 19, continuing our journey. After doing introduction to networking yesterday, I'm going to expand upon that knowledge here a little bit and start talking about the TCP IP protocols, the engine essentially that drives the internet itself. Our objectives for this particular session are going to be to explain the purpose and role of TCP IP in the internet or private networks, explain the characteristics and properties of TCP IP, and explain common TCP and UDP ports and protocols and their purposes. And we'll be able to understand the difference between TCP and UDP. When would you use these things? Why are they important? BSMs we want to take into account while working through this particular one: adaptability. We are throwing a lot of information at you. You've got to be able to adapt to it, be able to incorporate it into your learning style, and grow and develop as we move along. Also, personal responsibility. Want to make sure that we're doing the readings, we're doing the homework as best we can, trying to keep up to the best of our abilities. If we start to fall behind, reach out to our teammates, ask for help. Reach out to Marvin and myself, ask for help. That's part of personal responsibility. Don't be afraid to ask for help. We will not mock you for it. We will not turn you away. If there's any way we can help, we are here to do that for you. I bet it's true for most of your classmates as well. Please don't neglect these study groups. I hope they haven't fallen off by this point. They should be ramping up, because your classmates are going to be some of your best assets working throughout this program, not just here, but after this program. This is a great networking opportunity. You know, as some of you are successful, you'll be able to see opportunities that may help out others, and vice versa. Stay in contact. Continue to reach out to each other. All right. TCP IP overview. What exactly is a protocol? We see that word an awful lot in the acronyms we work with on a daily basis. If we ever see a P in there, we know, yeah, that's got to be protocol. So what exactly is a protocol? Essentially, it is a set of rules that have been predetermined and agreed upon for electronic communication. Now, let's dive in a little bit deeper. What is TCP IP? Well, we got two P's in there, and they both mean protocol. So it stands for Transmission Control Protocol / Internet Protocol. And it's essentially a suite or collection of protocols used to communicate over the most modern networks, including the World Wide Web or internet as a whole. Yes, Jimmy.
When it says a collection, it is speaking to just two or more.
Yes.
So it's just transmission.
There are a lot of protocols that operate over the internet. So this is like kind of the umbrella collection of them.
Okay.
Does it make sense? So yeah, there is two or more protocols that go into this. Absolutely.
So it's more than two. It's not just a transmission control and the internet protocol.
Correct. Because there are other protocols that operate underneath those.
Okay.
So based off of what we were talking about yesterday, what is a host? Host is any machine or interface. Could be a phone. Heck, it could be a smoke detector. It could be your doorbell. Could be your refrigerator. If they are connected to the internet, they would be a host. Be able to interface and participate in the TCP IP network as either a client or as a server. Now, communication protocols. as we talked about, they are essentially a set of rules to govern network communication. A suite is a group of protocols that operate together. And the most popular one in use today is TCP/IP. There are others out there that are used on some private networks. It is exceedingly rare that you will come across something like that, but they are still out there. For the most part, people have converted over to the TCP/IP because it's just easier to utilize the same protocols for the external network as you do for the internal. Some of the previous protocols that have, kind of gone by the wayside, we have Apple Talk. Guess who made it? We have Interwork Packet Exchange, Sequence Packet Exchange, or IPX SPX. Then you have Networked Basic Input Output Systems, or NetBIOS. That one, if you do come across one, that is likely going to be the one you're going to come across. And then Enhanced User Interface, or NetBUI. All right. Here is where a little bit of confusion starts to set in, because there are 3 different ways we look at basically the same thing. Coursera talked about the TCP/IP model, or 5-layer model, which is their version of it, how they view it. Another way we can view it is the DoD model, which was created by the Department of Defense. And then you have the OSI model. And basically all they're doing is some of them clump different layers together because it makes it easier to, manipulate. And I believe with the Google 5-step model, they basically take the top 3 layers and just clump them all together in application layer. DoD marks it down into 4 layers. You have the application, the transport, the internet, and the network access. Here, they clump the bottom 2 together. So the physical and the data link layer are combined together. And then the top 3, the session, application, I forget what P is, presentation. Session, presentation, and application layers are all combined together in this top layer of this one, all in the application model. So, but just slightly different. Google breaks up the bottom 2. The network access layer becomes physical and data link. All right. I hate this picture because it really does not represent what's going on. So let's see if we can just bypass it. So you go back to it. Okay, well, come back here. So over here in OSI, I'm going right off the side here. We got 7 layers. You have your P, which is your physical. You have your D, which is your data link. N, which is your network layer, which marries up with the internet layer of DoD. Network access is the combination of these 2 here. And it's telling you in the middle over here what the protocols being used in these processes are. Transport layer is the same across the board. And then you have session, presentation, and application at the top up here. You don't need to have a thorough in-depth knowledge as to what's happening on each stage of the OSI layers. You should be familiar with the protocols that happen on those layers. But if you continue on into Network Plus, you will need to have a much better understanding of the OSI models and how data actually moves through the process. Like in this particular case, up in the application layer, application, presentation, and session layers. So like you have a chunk of data that you're about to send, and then you're sending it from here, but you're trying to connect to a web server. So on that web server, in order to connect to it, you're going to need to go into port 80, which is HTTP, which is your Hypertext Transfer Protocol port. So that is how you would connect to a web server. So you're going to encapsulate that data and then put on the outer sides, I'm sending this from port 4500 and I want to connect to port 80. So that encapsulates that data. It moves down to the next layer. The next layer is the TCP UDP layers. So we're going to say, do we want a connection oriented or essentially a speed oriented connection? You know, am I sending this express mail so it gets there as quick as possible? Or am I sending this with security to verify that everything I'm sending is getting there? TCP is essentially, there's a check on that data. So when I send something to you, say I'm sending 50 packets, it's the first piece is saying, okay, 50 packets should be coming. Each of the packets are numbered. They start coming in, and then it says, okay, did you receive 50 packets? It'll look through and say, no, I didn't receive packet 26 and 13. And it says, okay, I'll resend 26 and 13. That's TCP. UDP doesn't care. It just keeps firing the data at you, and you're capturing everything you can and being able to absorb what you can. A good example of this would be like this Zoom call, or if you're streaming something from Netflix, you don't need it to go back and fix a picture from 30 seconds ago because it didn't receive that packet. You want it to continue trying to receive packets that are coming in the future in this constant stream. So it's not trying to guarantee everything is getting there. It's trying to give you the best service possible with the fastest communication. So that would be the difference between TCP and UDP. We will get into it more. That's just kind of a brief overview. So you're encapsulating that data a little bit more. You're putting the, you know, whether it's going to be connection oriented or not, then it moves down to the next layer. Now we're putting in there, where's it going? Well, say we want to talk to Google and their DNS server. So we know that IP address is 8.8.8.8. So we put that as our destination, and then we will put our IP address as the origin, which will go on the front and back of that packet. So that gets encapsulated again. It moves down one more step. We get into the frame relay. Now we're talking MAC addresses because we haven't got out into the internet yet. We're still on our network. How does the packet get out of our network? Okay, well, so we need to put our MAC address so that, you know, they know where this packet came from, put that on the outer edge. And then on the front end of it, we're going to put the destination MAC address, which would be our gateway to get out into the world. So we've now put all this information around our data before it even goes out of our computer. It's amazing to think that all this gets done in a microsecond. And so once it leaves, it goes to the router. The router picks up the MAC address and says, okay, well, this came from Marvin. So we'll strip off, we'll hold Marvin's MAC address just so we know where to send it back to when this comes. I see the IP address is there. So we've peeled off the MAC address. We now send it on its way. So the IP address tells it exactly where it needs to go. It hits that destination. As soon as it hits their router, the router picks it up and sends it to whichever server wants to deal with it. They peel off the IP address, leave the internal component for port number, say, okay, we want to interact with that, that web address. So let's go ahead and shove it over to the web address ports so it can communicate. And then the whole process happens all over again when it sends that information right back to you. All that stuff gets encapsulated again, comes over, and then as it goes through these layers of the OSI, it starts peeling those layers off to get down to the data that you need from the outside. You don't really need to remember all of this at one time. This is kind of just giving you an overview how data moves through your computer. When you're reaching out to other systems and then they're communicating back with you, all this stuff is repeatedly happening thousands of times a second because these data packets aren't really that big. And so for basic information, you may be sending out thousands of packets. I know that was a lot. Yeah, go ahead, Justin.
So the Ethernet framework and the IP datagram gets done before it even gets to the first IP address. Is that right? Like I'm trying to put the order together.
So up here in the application layer, that's where your data is. And I'm trying to remember the exact terms they use for each layer. I always get those a little bit mixed up.
But the application is the last, like that's the stopping point.
So your
right?
application is your top layer. That's what you interact with. And so I believe that would be the what they would consider the datagram. And then you start encapsulating all that stuff around it. I mean, it becomes a frame, it becomes like a segment, a frame, I got to remember the order to which it
I get
it
it.
escalates.
I just had mine backwards. Okay.
So, all right. Kind of building upon that, because that was just like a brief overview. We'll get into some of that stuff in a little more detail. Application protocols. One of the most common ones you will interact with would be HTTP, or Hypertext Transfer Protocol. This is the protocol that basically tells the web servers how they will talk to each other, or they will talk to you. How will the relationship be between you and them? It defines essentially the content, the formatting, how the requests need to be made, and how they will be exchanged between client and server. Now, we will talk about transport protocols. The two main ones we just talked about were TCP and UDP. Think of it kind of like you're sending a letter. You know, TCP, you want to confirm everything gets there. So if it's like a document, you want to be sure all the pieces of that document arrive. And so that document is a complete piece. So the TCP verifies all the data has been received. Now, sorry, go back here real quick. And basically, like we're talking about, if any piece of data you're sending, it's broken down into smaller chunks, encapsulated in these packets that we were talking about, or segments, and sent on to the servers themselves, and then they respond with a bunch of smaller packets as well. And your computer will reassemble those once they have arrived. Your internet protocol is responsible for formatting those segments, making sure that, you know, it's not a bunch of garbled mess when you see it. It's actually makes sense, put into the proper order. And other pieces of the encapsulation process will tell you the packet, what it is, what order it is, what protocols it needs to use. There's a lot more that goes into it. That was just kind of a rough overview of what happens as far as just getting the message to where it needs to go. And the internet protocol is also looking for the best path to the destination host. That's not necessarily a straight line. So when you're communicating with routers essentially rule the internet. They determine everything that passes through, and even the router at your house may be used to pass information through. You can actually trace the packets that you send out over the internet and see how many places it hits along the way to get to its destination. So you can actually follow those packets along their journey through the internet and see, you know, like if I send it from here in Florida, it may go to, you know, my local ISP here in Jacksonville, then it goes to Atlanta, and then it will go to somewhere in Kansas, and then maybe drop down to Texas, and then shoot up to Nevada, and then finally go to California. So it's not necessarily going to be a straight line. It's looking for the most efficient path possible. And if one of those nodes seems to go offline, it has to find a way around that. Or if it's seeing high traffic and it's running slow, it needs to find the best path forward for you. And so these routers communicate with each other. A single router doesn't know every router on the internet, but it knows all the ones that are connected to it. And so it keeps up with all the ones that are directly connected to it. And then the ones they're connected to keep track of all that are connected to them. And so it works through that process. So like, I may not know how to communicate with Avery, but I can communicate with Marvin. And Marvin knows how to communicate with Avery. So I send the packet to Marvin, and then Marvin goes, okay, Avery's on channel 7. I can forward it on to Avery from here. All right. Next, we have Network Access Protocol. This is a data link management protocol. It takes the packets from IP and formats them to be transmitted over the media, whatever media you're using, being coax, fiber optic, twisted pair, what have you. So it formats it to be able to be pushed over that medium. It uses the standards and protocols for the physical media that you have and how the signals are to be sent. Because obviously, if we're sending it fiber optically from our computer, that's going to require something different than if we send it over a copper line. So the interaction will be different. No, don't freeze up on me. So, in dealing with the internet protocols, we have to be able to communicate over the internet. So we have to utilize a certain set of standards. Now, we're going to be diving into this a little bit here. We need to be familiar with IP addresses. And underneath like IP addresses, we need to understand what a subnet mask is, what it's used for, why on earth we need to deal with such a thing. Is it just to give us headaches on a regular basis? Possibly. But they are important within internal networks as well as being able to find networks. We're going to be talking about IP version 4. Mostly, that is the bulk of what we will be talking about. And we got to get into classes. Like, you know, what's the difference between a class A and a class B? What about class C, D, E? You know, it even gets into there. So we got to talk about the classifications of IP addresses. What is a public address versus what is a private address? We do need to be able to know that on site. Are we dealing with a public address or a private address? A PIPA. It's not just a fun word to say. It actually has meaning. What is the importance of a PIPA? When should it be used? What does that tell us in the troubleshooting process if we see it being used? So a PIPA is pretty important. And then you have your basic communication. And then we get into IP version 6. We need to understand the rules of IP version 6. How do we get into the shorthand? How do we take this really long IP address and shrink it down to where it's manageable? What about different types of addresses we need to know of IP version 6 as well? There we go. So IP address is it's a unique identification number for any device that is on the network. So phones, computers, tablets, TVs, entertainment centers, gaming consoles, refrigerators, almost anything you can think of. For some reason, we have dryers, washers and dryers on the internet. We have dishwashers on the internet now, stoves, all of that stuff. I mean, granted, I can see from a safety standpoint, if you want to check and see if your stove's on, okay, you can be able to do that remotely. But more and more things are getting IP addresses. Essentially, the IP address is kind of like the telephone number to that unique device. It's how do you dial it up? It identifies, the number itself identifies the network to which they are operating on and which host you're going to be communicating with on that network. So remember on the MAC address, for like the first 3 octets or first 3 bytes of the MAC address were for the manufacturer, and the last 3 was for that unique device. This is kind of like that same thing where the IP address might be for the city you live in. So the first part of it would be the city you live in, and the last part might be your street address. So that's how you're going to be breaking it up. So you'll be breaking it up into network and host, and we'll show you how to do that. And that's where CIDR subnetting and stuff like that and the subnet mask become important to understanding how to route packets through a network. All right. Now, how are IP addresses assigned? Well, they're assigned by IANA. IANA, the Internet Assigned Numbers Authority. They're responsible for keeping track and assigning IP addresses. You don't just get one willy-nilly whenever you go onto the internet. Your internet service provider has a set number of them for you. They may allocate one for you, but my guess is you're operating off of a private IP address. Sorry, we said flyby. Private IP address. And they're just divvying out to you a small portion of that network. Now, IP version 4. This is the one many of us are most comfortable with seeing. It is a 32-bit address that is broken down into 4 bytes, 4 octets. So another word for a byte is an octet. It just means 8. So you have 8 ones or zeros, then you have a semicolon, 8 ones or zeros, semicolon, 8 ones or zeros, semicolon, 8 ones or zeros. So it's 32 of those broken up into 8 or 4 octets, 4 groups of 8. When we see it, it looks much like this right here, this 192.168.254.255. So that is what an IP address would look like normally when you look at it. But as we remember from our binary counting, we can do this in binary. So we know how to make 192 in binary, right? Right? So we did do that.
Yes,
and that's
we do.
all they're doing here. I'm sorry, go ahead, Marvin.
No, I'm saying, yes, we do. We know how to do that.
Yeah. So we know how to do that. But see, the computer itself is not seeing the 192.168.254. It's seeing 111.010.10.11.0.110.110.110.0.0.0.111. That's all it's seeing. It's being translated into this format right here to make it easier for us to read. Now, in any given group, right here, in any one of these octets, we could go from, we have 256 options. So we can go from 0 to 255. If we see anything over 255, that is not a valid IP. It does not work. It has more than 4 billion unique addresses, which seemed like such an awesome number back in the 80s when they put this protocol in place. Little did they know, by the mid-90s, they would be running out of those addresses already. So we had to do some internet magic to buy us some time while we figure out what to do. Lo and behold, we come up with IP version 6. So rather than 32-bit address, we now have a 128-bit address, significantly longer. And not only that, we're not using the standard octet rules anymore. We're now using hexadecimals, which we went over yesterday. So we can go 0 through 9, and then all, A through F are used for 10 through 15. So we can write an address out, and this was what it would kind of look like down here. This is a shorthand version. It is not a full address. We can tell by the double colon that is set right there that it has been shortened. This was put into place to solve the lack of IP addresses, and I think we talked about it earlier. This allows for 340 undecillion addresses. If you don't know what an undecillion is, that is 32 zeros behind the 340. So that is a really big number. More grains of sand on the earth than IP addresses available, or excuse me, more IP addresses available than grains of sand on the earth at this point. Take what I said, flip it, reverse it. There we go. So we should not be running out of these anytime soon, unless they literally start slapping IPs on absolutely everything. Although why you would want an apple or a banana to have an IP address, I don't know. Somebody will figure out a way to do it though. Yeah, Matrix probably. All right, the subnet mask. Dreaded word we have all been fearing. moving through this process. What is it? What does it do? Why do we have to put up with it? The subnet mask's sole purpose is to identify for the computer what portion of the address is going to be dedicated to the network and what portion of the address would be dedicated to the host itself. So a subnet mask is typically consists of a series of contiguous ones followed by a set of zeros. What that means is, go ahead and annotate here, go ahead, text. So when I'm typing it out, let me see if it'll let me. All right. So if I'm typing it out, I got all right. So we can see this here.
Yes.
So you see how I got a series of ones right here. So turn on all these ones, and then all of a sudden I'm turning on nothing but zeros. So that's what they mean by this, a contiguous set of ones followed by a series of zeros. So everywhere where there is a 1, that is your network address. Anything that follows after that is a host address. Based off of what I'm showing here, this is a class B. How this would be written in shorthand to make it easier for us to see and deal with. Please excuse the fact that I use semicolons instead of periods on that last one. That is actually a mistake. If you see semicolons like that, that's wrong. It needs to be periods like this. So the shorthand version of what I have written down here is 255.255.0.0 or a class B address. So this lets the computer know when it receives an address. First, it'll receive the subnet mask and it'll receive an address. It tells you exactly which portion of that IP belongs to the network, which portion belongs to the host. So if we write out a IP address, like this, 192.168.15.235. If we have that address based off of the subnet mask I'm showing you here, this 255.255.0.0, that tells us this first 2 groups right here, 192.168, that's our network. And then the 15.235, that's the identifier of the host on that network. Does that make sense? I'm not getting any nods on this. So do I need to go a little bit deeper?
No, man, you're laying down the foundation. It's hard to, they're following.
What were you to say, Mark?
Ask questions, guys, ask questions, because I am. This is my kryptonite.
All right. It can be written in this format, which is this will be one of the, I changed my pen here. So it can be written likely in this format up here. This is what you would see. This is what the computer sees right here. But there's another way it can be notated. And on this, you would see a /16. So /16 tells us that it was 16 ones, so 2 octets, for the network. And then the last 16 would be dedicated to the host. If it was a class A, where it was just 255.0.0.0, then it would be a /8, because only the first 8 ones would be there, and then the last 24 would be all zeros. Yes, Justin.
So when you got the one where you got all ones and then all zeros, that's the subnet mask in binary, right?
Yes,
Okay.
that's how the subnet mask would be written in binary. Exactly.
But you also have a binary just for the IP too, right? If I
Yes.
remember that video right. Okay.
But what's going on is the subnet mask is telling the computer which portion of that IP address. So like on this 192.168 with this, you know, this 16 ones and 16 zeros, we know this first section of the IP right here, that's the network.
Correct.
And then this last portion here, that's the computer on that network that we're talking to.
Okay. Because
So,
what I just learned new was the amount of ones that is
Yeah.
16 ones in the subnet mask binary portion. Because what I usually do is like say I seen 24 there, right?
mhm,
And I just know it's only 8 bits in an octet.
yeah,
I divide it by 8, and that's how I know which portion is the network versus the host.
yeah. I mean, if that helps you remember it, that's a great way to do it.
Changes depends on class.
Yeah, it is. So the class, all this leads into IP class identification.
Gotcha. Okay.
So, but first we're just trying to say, we're trying to set that foundation as to what it is that makes the class, why the subnet is important. Yes, Mark.
You go over the slash notation again. I want to make sure I understand it.
Okay. So let me go ahead and no, undo. All right. So you see how we had the 16 ones and then the 16 zeros. So this would be a class B because the first 2 are dedicated to it. So because we have 16 ones, that's why you would see that /16. That is a shorthand way of identifying the subnet mask. So it's just quick and easy to spot. That is the exact same as saying up here, this 255.255.0.0. Does everybody understands where that 255 is coming from? If we turn on all 8 bits, add it all up, we get 255 in binary. So that's where that is coming from, that 255. That's all 8 bits in binary being turned on. Yes, Umberto.
Yes, so you count the number of 1 starting from the left. How many ones since the first bit to know if it is a /8 or a /16?
Correct. And mind you, this will never be jumbled up. It won't be like 10010000111. No, it is a series of ones up until it is a series of zeros. They don't mix it up. That makes it easy for the computer to identify and for you to identify. And that's how you determine your subnet mask. So we okay on this? We don't need to be experts on it, but are we okay on it? Yes, Evan.
Could it be mixed up? Like, is it possible?
Not for a subnet mask, no. Because the computer would not know how to interact with it at that point. Now for an IP address, yes. Specifically for the subnet mask, it is a series of ones and then a series of zeros. That's it. They don't shuffle around, they don't mix up.
In that order, like it has to have the ones, like the ones have to be first.
Yes, ones first, then zeros. It does not go the other way around.
Okay.
All right. Any other questions? right. So let's talk about various classes. Now, class A, as you can see here, the classful mask, the setup of the subnet mask right here. Class A is 255.0.0.0. That means the first 8 bits are on, last 24 bits are 0 in the subnet mask, or it is a /8 notation. Class B, 255.255.0.0 means the first 16 bits are turned on, the last 16 bits are turned off. Our notation here is a /16 for class B. Class C, which is the last major class, 255.255.255.0. So the first 24 bits are on, the last 8 bits are off, and has a /24. Class D is typically used for multicast networks. So it is reserved for that, and E is reserved for experimental use. So you will very rarely, if ever, deal with class D or E. Most of your world will be spent in the first 3, class A, B, and C. Now, interestingly, you're probably sitting there wondering, are these numbers arbitrary? I mean, is it just random? And the answer is no, it is not random, actually. So class A, trying to think here. So if you remember when we laid out all the binary, you had 1, 2, 4, 8, 16, 32, 64, 128, right? So anything under 128, because that would be the first bit clicked on for class A. So anything up until that first click is class A, allotting for any address starting between 1 and 126 is a class A. Class A allows for the most amount of hosts on a network. I think they get into that in the next slide. We'll talk about that. But it is the largest groups. It's usually used for like universities, countries, stuff like that, because there's a ton of IP addresses on a class A. Class B would be large to mid-sized companies, like Google would be a class A. Comcast would be a class A. Then we get into class B. That would be very large companies, things of that nature. And then you get into class C, which are very small companies or small businesses or homes use and stuff like that. So remember how we were talking about which portion is dedicated to the network and which portion is dedicated to the host, right? So if we look at the subnet mask again, change my color here. We look at the subnet mask here, class A. Wow, that color did not show up at all. Let's try that one more time. Is that better, or we want a different color?
It's better.
All right. So look here, so we know that the first section, this octet, allows for, just the first octet to be the network. The last 3 are set to be for the host on that network, right? So this would allow for only 255 networks, very large networks. So 255 large networks, that's all we can have. So there's only 255 large networks, but it allows for, I gotta do the math here real quick. No, it's exponential. Never mind. It's something like 10 million hosts or something like that on a network. So think of it like cities. The network's like cities. How many cities in the world do you think are like the size of New York City?
Maybe
50? Do what?
I was about to say, not many.
Not many, right?
100.
Maybe 100, maybe 100. So, you know, if we're talking just cities, there's not that many of major cities. We start getting into mid-sized cities like Indianapolis and maybe Greensboro, North Carolina, or something like that. Getting to mid-sized cities. How many mid-sized cities do you think there are?
10,000.
Probably significantly more than there were large cities, right? But still, you know, maybe not like a whole ton of them. Then we look at Class C. That's like a small city, like a small rural town or something like that. How many of those do you think there are? Small suburbs or rural towns? Anybody who's ever been to the Dallas area, there's like 1,000 small towns that just surround the DFW area. So there are tens of thousands of small towns, but in these small towns, you don't need as many addresses, right? So these small rural towns, you only need about up to 255 addresses. So that's your really small networks. They can have up to 255 hosts. Then we get to the mid-sized cities. There's a lot more people, right, than the small towns. So you're going to need quite a bit bigger chunk. So that gives you more addresses. Then you get to places like New York City where you need millions of addresses just to be able to sustain it. So there aren't that many cities, but there's a ton of people in each one of those cities. So that's kind of how we look at it. So the bigger the network, there's not that many of them, but they have a ton of people on each network. Smaller homes and businesses, there's a ton of those smaller homes and businesses, but they don't usually have a lot of people on there. They may have 10, 15, 20, you know, something along those lines. So that's where these classifications come into play and allows us to divvy out addresses as needed. So expand on this a little bit more. So here's where we're talking about it. So in a Class A network, you could have, I think the total on this is they have 126 networks and 16,777,214 hosts on each one of those networks. That's a lot, right? That's a lot of computers. Then you get the mid-sized networks, you have 16,384 of those, and then you can have 665,000 hosts on each. And then you get down to the small networks, there's like over 2 million of these tiny little networks, and they can have up to 254 hosts on them. Quick question. How would we notate the subnet mask on this one right here? Is Class B?
We could have two byte, 2 octets for the network and 2 for the host.
Okay. So how would we notate that? Justin.
If it's 2 octets, that's going to be 8 times 2, so it'll be /16 for the CIDR.
There you go. So there you go. /16. That's one way to notate it. How else would we notate it? What's another way? Let's get someone else for that. What's another way we can notate that /16?
255.255.00.
There you go. .0.0. Excellent. It's Class B. Very good. All right. Public addresses. These are
Mark,
to
do
be
you have a
used.
question, or did you?
Yeah, I had a quick question before you switch. Kelly, is there a
Okay.
formula for determining the number of networks and hosts, or is that something we should concentrate on learning?
Well, yeah, there is a formula. It's basically, it grows exponentially. So it's you continue to double it as you go. So,
It's like
you know,
into the
like when we
grid or
get up to
something.
255, after we get to 255, what is it? It's 512,
Yep.
and then
512,
10,
10, 20,
24.
24, 20, 48.
Yeah, and so
90,
it's exponential
49.
growth with the adding of each bit. So depending on how many bits determines how many hosts, how many networks. When we get into CIDR subnetting, that will make a little bit more sense when we start breaking things down into smaller chunks.
But as it stands right now, Mark, it's not pertinent or necessary for what we're doing.
Good question, though. All right, public IP addresses. Now, this is usually received from your ISP, and they are classed by the first octet. As we were talking about earlier, if that's 0 to 126, that's for the very large networks. And that's for your first octet. When you look at an IP address, you should be able to see an IP address right off the bat and go, okay, that's a class B, that's a class C, that's a class, A. Based off of the number you're seeing, you should be able to tell which class IP address it is. Because if it's anything between 0 and 126, that's an A. 128 to 191, that's a B. 192 to 223, it's a C. And then you have the multicasting and testing purposes beyond that.
Has anyone, there you go, TK. I was waiting on it. TK, can you ask it out loud or you?
Is 127 not used?
Oh, it's used. It is absolutely used. And that's a great observation. I like that.
Right.
That is a very special IP address range. That is called the loopback address. So based off of that, where have we heard loopback before?
With that connector we did yesterday?
There you go. Loopback plug. What did it do?
Test the NIC.
Test the NIC to make sure it's working, right? This is a software version to do the exact same thing. So you can ping 127.0.0.1 or 127. Whatever, and you will ping your NIC on your computer, and it will tell you if it's working, if it's responsive, if it's responding. So that specific grouping has been set aside specifically for the loopback address, and that is one you will need to know. So whenever you see 127.0 or dot whatever, that is a loopback address used to test your NIC.
Good catch, TK. I'm glad because
Yeah,
I was
about
to push it out. I was like, so somebody don't see something? I know y'all, something's missing up here. So I'm glad that you caught that. Kelly said it really well. The plug is the physical way to connect it, to test it, and this is the software way to test it. That's really, and typically, although it has the whole range, typically you would see it the way that I put it in the way that Kelly said. But if they try to trip you up and throw out some more numbers, it's the whole range of 127.
Yeah. Yes.
What you have, Justin?
So that don't got nothing to do with the true reserved IP addresses used by the subnet mask, right? That's something like totally different, right?
Yes, totally different. Remember, the subnet mask's sole purpose is to tell, like when I'm sending an IP address through the network, the sole purpose of it is to identify first the network it's going to. Like I'm sending a package. First, I want to identify it's going to New York City. And then once it gets to New York City, I want to identify it's going to apartment C on 105th Street, 567 105th Street. So first we want to identify which network it's going to go to, and then what house or what address on that network we want to speak to.
Big picture first, Justin, and then we get very specific.
So, and then the address, that IP address we're using, the 127.0.0.1, is basically just sending a signal to our NIC that's on our computer, just making sure that it is functioning properly. And it'll tell you, yep, 4 packets received, 4 packets sent, all good. Any other questions so far? All right. Now, this kind of wraps it up here a little bit, lets us know your address range for private addresses. Now, what is the difference between a private and a public address? Why would we use a private address?
Them little women nasty, girl. Them little women nasty as hell.
So, why would we use a private address?
It's more secure.
No, it actually comes down to us running out of addresses. We were running out of IPs. Remember, we were saying that back in 96, we were running out of IPs. So in a way to kind of get around this, we have blocked off little chunks of network IP addresses that could be used on internal networks only. They cannot be routed over the internet. So we use something that's called Network Address Translation, or NAT. This is a very elegant solution to a complex problem where we were running out of IP addresses. So what happens is internally on your network, you can run around with one of these addresses here that they have listed. Depending on your carrier would determine which one of these you're using. So when I go to my, like if I have a medium-sized company and I have 500 employees, whatever, that need to communicate on the net, I don't want to buy 500 IP addresses. That would be extremely expensive for me to have. So I may buy like 2, even though I have 500 employees, and they'll share it. So what happens is when they're routing on the internal networks, they'll use these private IP addresses. And then when something needs to go out into the internet, when it hits the external router, the router takes off the IP address that it has, puts its own IP address in the front, and sends it out over the net. So you're able to use a whole lot more computers on significantly fewer external IPs. So private, used inside your company, inside your network, but can't be routed over the internet. Once it gets out over the internet, there has to be a public IP address attached. Here are the ranges for your IPs for private ones. You have 10, anything in the 10 range. That is a class A private. Anybody have Comcast? If you have Comcast or Xfinity as your IP, as your internet provider, likely you have a class A private address on your internal network that you're using at your house. Class B would be 172.16 all the way up to 172.31. So that's your class B. Also in class B, you have 169.254 range as well.
Why is it split, class B?
Probably because they needed more within that range. Like the initial one was just not sufficient, so they had to add more to it. And then in class C, 192.168. If you ever see that, you know it's a private address. Yes, Justin.
The private address, that's NAT, right? The network address translation.
Well, no, what happens is when you're using that private address, when it touches the router, the external router uses NAT, network address translation, to change that internal address, that private address, into a public address. So everybody internally is using the public facing IP of the router, but they don't see that. Which is why, interestingly, if you have, you go in and you look up your IP address, it'll tell you it's like 10.5.5.0 or something like that. And then you can Google what's my IP address, and it'll give you a totally different address, because the external router address is what Google is seeing, not your internal computer. Because the router itself is translating that address into a public one so it can talk over the internet.
Gotcha.
So private can't talk in the open free internet. That's where public addresses are used. And this is a way to kind of just save IP addresses so they don't get all burned up. Any other questions? All right, so continuing on here a little bit, we see that we have this 127.0.0.1 that we were talking about earlier, the loopback address, which is basically home. That's, you know, you're just checking to make sure you're okay, you're working. If you see an address of 0.0.0, that is an unassigned IP address, and there are things in place where you should not really ever see this come up. But if you ever do, it means like no IP address has been assigned to this computer at all. And then the other side of that coin, 255.255.255.255, that is the broadcast address. That sends it out to everybody. And if you ever see 255 on the end right here, that is always the broadcast address. So even if you had 192.168.0.255, it would send a broadcast out to everybody on that network. So time to climb. Are we ready? Did space this morning. Let's do the ice today. All right. After the time to climb, we'll take a quick 5-minute break just to kind of absorb what we're taking in here. All right, are we ready? Here we go. At 255.0.0. /8. Class A. .0.0.0. Also Class A. /16. Class B. finally, 255.255.255.0. All right. Top 3. Justin, on the podium, sir. Mark and TJ round out the top 5 with TK and Fidel. Okay. On to a PIPA. What is a PIPA? Well, it is an automatic private IP addressing is what that stands for. A PIPA, automatic private IP addressing. It is a TCP/IP feature that Microsoft themselves added to its operating systems to kind of help with communication. So if your computer cannot communicate with the DHCP server, which the DHCP server is the one that hands out IP addresses, if it is unable to communicate with the DHCP server, it can auto-calculate an IPIPA address, which typically starts with 169.254. something. And what this does, it allows you to communicate on your internal network. So you can diagnose issues. So you can figure out what's going on with the DHCP server. Are you able to communicate with other computers? Can they see you? And all that kind of stuff. So the IPIPA allows you to kind of have rudimentary connection on the internet to diagnose problems. It will not allow you to go out into the greater internet. So when you hear people mention, hey, I can talk to the network printer, I can send direct messages to my boss, but I can't go to this website. Any website I try, I can't get to any website, but I know I'm on the internet. I can talk to the network printer. I've printed devices, or I've printed documents. It's because likely they're using an IPIPA address. So the first thing you would want to do is go in and check, look at the IP address and see if you see this 169.254 address. That would tell you that they are not communicating with the DHCP.
Does anybody know what a DHCP is?
Stands for.
Yeah, because we throwing it around, but I don't know if we gave you the purpose of it. So Mark, you're good. I need to see some head shakes. DHCP, does that ring a bell to anybody? TK, you know what DHCP?
Now earlier you didn't want me to talk. Now you calling on me. I don't know that.
All right. Well, now,
Dynamic,
all right. So
Dynamic, there we go, get the first one.
dynamic host configuration protocol.
that's it.
There
So
you go.
if a DHCP is there to provide you with a IP address randomly, but it's not random on the DHCP side. So you're not stuck with something that with a static. Really, really very popular in bigger settings where devices are coming in and out. Like if Umberto, Mark, John, Evan, Renzi, we all work in the same department. And we're breaking in different devices each time. What happens if Mark brings in his laptop from 2 weeks that he kept away from the office, and then when he gets there, he realizes it's not working? It's because that IP address may have been given to another device, or not given one at all, and it's confused on why is it not working. So DHCP server, it is dynamic. That's that first word. So it's constantly providing a way to talk to everything on the internet if you had the right credentials. If you can get in there and get everything set up, it wants to let you talk. If it doesn't work, then it's like, what's going on? I'm confused. Something's not working. That 169.254 is the first thing that'll show up on your computer to let you know, hey, something's not jiving right. We're not doing what we need to do We want you to be able to talk a little bit. It's almost like in school when you didn't have that hall pass and somebody gives you a pass temporarily to walk throughout the halls. Now you can move around, but that's not your pass. We haven't fixed the problem. We still need to know where your pass is. And that's a way to identify that. And it really helps because when you see that, you know, oh, I got an automatic a private address. Something's not right in the world and I need to address it. So that's why they came up with this, and it will come up on the test. It will. So that's what a PIPA is. It's the ability to identify an issue with the network by you not getting the proper IP address.
There we go. Questions so far with regards to a PIPA?
Can you repeat that again? Or what a PIPA?
A PIPA. I'll say that as many times as I can. It's a fun word.
No, the ability to what?
It allows you to be able to communicate on the network if you're unable to talk to the Dhcp server, which is what gives you your IP addresses to talk over the net. So if you're unable to get that IP address, so you can't talk on the network, like out into the internet, the PIPA address at least allows you to talk over your internal network, that little tiny network you're in order to be able to troubleshoot, figure out what's going on, try to solve this problem, and even work with other computers inside that little network.
So this shows up when you don't have an IP address.
Yes.
When
you can't get an IP address, it gives you an PIPA. And so this is like one of those big troubleshooting steps that you want to look like if somebody says they can talk internally, like to network printers or what have you, but they can't get on the internet, then you go look at their IP address and see if they have an PIPA. And if they have an PIPA, then you know there's something going on with regards to them not being able to get an IP address, like not being able to communicate with the DHCP. If it's more widespread, you know, then you need to, you know, try to remedy this as quickly as possible. It could be that the DHCP server just ran out of IP addresses.
I was about to say that.
It happens.
Yeah.
So, yes, Humberto.
Yes, so with a PIPA, I will be able to communicate with peers of my own switch, but I can go with somebody else out of my switch.
Yes. So your own little network, you could talk to anybody outside of it. No. And they do that to allow for troubleshooting and stuff like that. And it is done automatically. Which is why we were saying if the 0.0.0.0 means nothing has been assigned, that's why we're saying it's rare that you would see that, because if they don't get an IP address, a PIPA is automatically assigned.
There you go.
All right. IP version 4. What's the difference between unicast, broadcast, and multicast? So unicast is from a single source to a single source. That's me talking directly to Marvin and him talking directly to me. Nobody else is involved. Broadcast is me talking to everybody on the network. I don't care whether you want to listen or not. I got something to say. So that's essentially a broadcast. And that's what we were talking about. If you see that 255 in that last octet, that is a broadcast address. Now you have multicast, which differs from broadcast to where it travels from a single source to specific group of multiple people, kind of like what we have here. I am multicasting to all of you. I'm not blasting it out to everybody in generation, just specifically you. This technically isn't a multicast because that would be a one-way communication. That'd be like if you're watching a like a quarterly report for a company, they may send you a link to a multicast. Graduation is a multicast for the most part, where it is a one-way communication. So, and this is done over the Class D address that we were talking about earlier. So, questions so far? Well, if you don't have an IP address, Luis, you would not be able to talk over the internet at all. You need an IP address. Now, whether or not you're using some other stuff that kind of hide that IP address, like you can do like IP spoofing or something like that to make it appear like your IP address is something else, that's a different story. But you need an IP to be able to communicate over the net.
Or if you're using a VPN, which you still have an IP address, but you're trying to find ways to either put it in a tunnel or bounce it around. That's different.
But even then, they're external where you pop out. Like if you're popping out, like you want to be in Canada or something. Like if you're popping out up there, you would have a different IP address than the one you would have at your house going into that VPN.
That's true.
Do hackers use that?
All the time. They were actually good at this long before it became a public service. This was something that they would try to do to hide where they were located and make it difficult to track, because they could set it to 20 or 30 different points. So you track them down to one point, you get there, you realize they're not there, they're in another point. You got to go track them to another point. So yes, hackers definitely use services like this. You'll learn pretty quickly, especially if you start getting into security, the difference between a security professional and a hacker essentially is just how they use the tools. Yeah. You're using the same tools, but in a different way. Because, I guess it's kind of like the Force. It can be used for good or evil.
See there? I know about the Force.
So, all right. So unicast, broadcast, multicast. All right, IP version 6. Now it's getting fun. Has 128-bit addresses. It is a really long address, and it is broken down into 32 hexadecimals divided into 8 fields. So you have 8 groups. 1, 2, 3, 4, 5, 6, 7, and 8. So 8 groups. So any groups of contiguous zeros containing all zeros, if you have 2 or 3 groups of all zeros, can be represented with a double colon. This is a way to shorthand it. So you don't have to write out 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and it get, really tedious, and then you have to go back and count all the ones you wrote. So right here, you have these 3 groups of zeros. So all you have to do is do a set of double colons, as you can see down here, and you can erase all those zeros in between. Caveat being, you can only do that one time. So you either do it with the leading group or the one with the most zeros. So this can only be done once. So you see how they have 2 groups here? They have like these groups of zeros, and then they have this group of zeros here. So they couldn't do 2 sets of double colons. If you do see 2 sets of double colons in an IP version 6 address, instantly you know that is not a valid IP. Because the reason being, if we did 2 sets of double colons like here and here, we know we have 4 missing groups of zeros, right? Because we got the 1 group here, then we have this 3 groups here, correct? So if we have 2 sets of double colons, how do we know how many groups? Is it going to be 2 groups of 4 zeros here, 2 groups of 4 zeros here? Is it one group of zeros here and 3 groups here, it can drastically change how the IP is configured if you do it more than one time. So it can only be used once. The other thing we can do is any leading zeros. So that at the beginning of the group. So you see this group of 4 here, it has 2 zeros up front. We can eliminate those 2 zeros and then just use CF because we know before it, there would be 2 zeros in place. We can shorthand the 4 zeros here by just doing a single zero because we know there would be 3 zeros in front of it at that point. So that is 2 ways in which you can shorten the IP version 6 address so that it is kind of easier to absorb or write or even type into the computer. Because trust me, you don't want to type in a 32 character address if you only have to type in 15. It also allows for less possibility for error. So does everybody understand that so far? Yes.
So let's say that those 3 sets of zeros was like after the BA, we could put the double colon after that, right? You understand what I'm saying? Like to
So
represent.
if it was after the BA and you had the
Yeah.
zeros right here, and then you had the 3 in the back, yeah, because you can use
Okay.
it one time, but I use it for the largest group of zeros. Now, if
Gotcha.
you just had one group of zeros up here and one group of zeros back here, typically use it at the first one. If they're the same, only use it for the first one.
Or could you
So-
just use 0? I'm sorry.
Go ahead. Janina, go ahead.
Oh, okay. Well, let's say you have a group of zeros on one end and a group of zeros on one end. You see how you have the 1 0 standing alone? Could you put that if for a group of zero, like, let's say there's 2 groups of zeros. Could you use 0 for both of those 2 groups of zeros in the spot that they belong?
Yeah. So say instead of the 3 groups of zeros here and the 1 back here, say it was 2 and 2. You could do the double colon for the first group and then do :0, :0, BA98.
Got you. Okay, thanks.
No problem. So you can still shorten it. Were you asking a question, TK?
Yeah, so it kind of goes along with what she just asked. The single zero took the place of the 4 zeros.
Yes. Because you're
So
getting rid
that's-
of all the leading zeros. So all the zeros that are in the front, you can get rid of. So you can see the 00 CF, you could eliminate those 2 zeros and just have CF. Because then you will know automatically the other 2 characters that come before it are zeros.
So if you had a group of 4 zeros, just one in the front, that can be :0.
Yep.
Okay.
If you've already used the double colon shortening method, the next group of 4 zeros would be :0.
And this is
Also,
it's all for compression, TK.
you-
Make it as small as you can.
You have to use double colons before you can use a single colon, 0, single colon.
You know, I mean, well, I mean, I'm saying you would want to go ahead and whatever the largest group of zeros, go ahead and, shorten it up for you as much as you can.
Like, what if you didn't need to do that? I guess that's what my question is.
Well, I'm saying if there was only, okay, so this was like this whole IP address, there was only one group of 4
Yeah.
zeros, then you would just do the double colons.
You double colon first.
Because that's still writing less than going :0.
Also, it'd still be double colon just for that one set of zeros.
Yeah.
Renzi had your hand up too.
Yeah, but I answered it. He answered it with the other questions.
Okay. I just caught what TK was asking. Yeah, you got to get the double colon out of the way before you start with the :0. So you just can't jump to :0. If there's only one opportunity to use it, you will double colon it up first.
Yep. And they do utilize subnet masks for IPv6. With the hash prefix, maximum you could have is 64. So up to essentially halfway. That'd be the maximum you could have for a subnet. And then the loopback address for IP version 6 is just : 1. So it's all zeros and then 1. Makes sense?
What was you just talking about? I was typing.
No problem. So down here is our loopback address, which is just : 1, which just means it's like 0, 0, 0, 0, 0, 31 times, and then a 1 on the end of it. Did I just connection to my mouse? This is fun. Marvin, can you pause the recording for a second? All right, IP version 6 address that we kind of need to be aware of. You have your Unicast, which is similar to Unicast on IP version 4, which is from a single user to a single user. You have the global Unicast, which can be routed over the internet. Most of them began with the 2000 in the first grouping. And then you have the link local Unicast. When you're talking about people on the same link, like your internal networks, most of them begin with FE80, followed by another enough zeros to make 64 bits essentially. Then you have the unique local address, which would identify a specific site within a large organization, and they start with FC00 or FD00 with a #7 or #8.
Gotcha.
What else? Go ahead.
No, I said got you.
Okay, then we have the multicast, which is kind of like the broadcast, but packets are delivered to all nodes on a particular network. And then we have the anycast, which is used by your routers, and it can identify multiple destinations, and packets are delivered to the closest because they're trying to find the shortest path to the destination and or quickest path. Sometimes the quickest path is not necessarily the shortest in distance. Questions so far? All right, we're halfway there. Next, how do we obtain the IP address? Well, we have a wonderful server called a Dhcp server, or Dynamic Host Configuration Protocol. And its main service is to assign IP addresses to anybody who needs them on the network. There's two ways this can be done. Either statically, to which you would not use a Dhcp server. And that would be, you have a list of IP addresses in the company. IT department has to maintain and track those IP addresses and enter them manually. And typically, if you come across an error in an IP address on that one, it is a human error. We can use both static and dynamic. Sometimes we would set static IP addresses to important things that should never change on the network, like the gateway server. We always want to know where that is, so we don't want that IP changing on us. Printers is another good one. You don't want to have to reconfigure the IP address to the printer every time the IPs are renewed. So you would have reserved IP addresses for certain items on your network that will never change. And again, if the DHCP fails, then you can use an APIPA to work within your network and try to troubleshoot what's going on. Now, if you want to know what the IP address is to your computer, If you are on a Windows computer, you would go into your command prompt, which is what are the two ways we can get to our command prompt? What are the two ways we can type it into search to find it?
Command
Or
CMD.
CMD. So you can go ahead and type that. It'll bring up the DOS screen, or it looks like the DOS screen. It's called the shell. And in there, you can type in IP config, which you see down here at the bottom of the screen right here. IP config. I guess it's // and that will give you a bunch of important information about your computer. It'll tell you your subnet mask, your IP address, your gateway server, all that kind of fun stuff. Generally, when you get into a network, if you are troubleshooting internet issues, this is one of the first things you're going to want to do. If you're on a Mac, you're going to want to search for terminal instead of command or CMD. And the command is going to be similar to this. Instead of IP config /all, it's going to be IF, F as in Frank, config /all. Questions? Did I hear you, Umberto? Okay. So that would be where you would go to find out your network information for your computer. Yes, TK.
I got a question. On the test out loud that we did, I think it was today, when we went to the start, we right click on start and we went to the PowerShell. Is that the same thing?
Kinda.
Okay.
It can be used as it can be used the same.
Another question here. How do hackers obtain your IP address so easily? Like, how do they do that?
Well, anytime you're communicating with my machine would need to know an IP address in order to communicate back with you.
So essentially, you're giving it to them in some way, Luis, through some connection that you make either directly or indirectly. You're giving them that ability to find it and to establish it and take it. I mean, it's more, they may have tools and they may have ways to get it, but
Yeah.
you gotta, I can't feel your hand if we never shake hands, you know? So somewhere there's a handshake happening. And it, like I said, it might not be by your doing, it's just the way that they're facilitating across the web and everything. And you give up that information. You gotta be careful out there, man.
I keep telling you that, Barbara.
I know, man.
Is it by clicking on certain sites? Is that a way of them getting in?
Yes.
Is that what you mean?
Possibility.
That is a possibility, yeah. Certain sites, hyperlinks, because they can infect a site. And then when you go to that site, you get infected.
You become a zombie, you become a bot, you work on their end. So it's a whole, we're gonna get into that. But like I say, it's just, if anything, just being more aware and not being so haphazard. Like, you know, everything that shows up on the browser doesn't require you to click on it. And you'll learn that.
I'm asking that because I saw a YouTuber and he figured out somebody's IP address, but just looking up the Microsoft account in Xbox. So I'm like, what the heck? So you can just like find somebody's IP address just looking up their Xbox gamer tag? Like, yo, that's scary.
I'm sure it was a little bit more to it, Louise, but yeah, that is kind of as, and then keep in mind, it could be, it doesn't have to always be his direct IP address. It could be like Kelly was saying, it could be your gateway.
Yeah.
And I mean, and that's still, you know, that information is very public, but if they can maneuver around that, who knows what all they can try to ascertain. But yeah, it's I can see what you're saying, but yeah, it's unfortunate, but you got some nefarious folks out there. Needless to say, we're gonna get you very comfortable with the internet, re-comfortable. So
Or, you know, depending on how you do your security, maybe less comfortable with the internet. I don't know.
But once you take the glasses off, you can't put them back on. So
That is
now-
true. That is true. Once you see it, you can't unsee it.
Yeah.
Yeah, it showed that in Coursera. I was like, what?
It's a dark world. It can be dark.
Yes, it can. All right. So in a computer, when you go look into your IP address and you go into advanced settings, you'll see a screen like this right here. This is going to basically the GUI version of the IP config to kind of show you where everything is. You can set your IP address to be static, meaning you put it in manually and you would have to fill in all of this information yourself, or you can have it be dynamic and it reaches out to the DHCP server and gets assigned from the server itself. The key pieces of information you need to always have are your IP address, subnet mask, and default gateway for your initial connection. Now, when you're dealing with websites and stuff like that, you would need to have a DNS server so it knows to go where to go to look up the IP address for common websites that you would go to. Now, on an internal DNS, you may have something like a WINS server that may work in lieu of a DNS server, but you will be informed ahead of that, informed about that ahead of time if that is the case. So, but predominantly it's the IP, subnet, and default, which would go up here, and then your DNS server. All right. Questions so far regarding DHCP? Just when you hear it, think about IP addresses. That's where you get them.
And what about the server?
The WINS server, that would be used predominantly on an intranet, something that would not be going outside to the internet. When you have multiple networks working together, like research facilities, something like that, they may utilize something like this in lieu of a DNS server, so instead of a DNS server. But this is something you would be made aware of ahead of time in your IT department if you need to set that up in as opposed to the DNS. Any other questions? All right. Static addressing configuration in an IP or in a PC. So we would go to our local area connections. We would go to set advanced. Oh, properties. Excuse me. Click on properties. Once you get to the properties, we would go down to our IP version 4 or 6, whichever we're using. Right click on that. Click on properties again. It will take us into this screen where we can configure the IP addresses as we see fit. If you're setting up a print server and you're using a computer for that, rather than an internal server on the printer itself, you can go in here and set a static IP to that computer. And again, this is where your problems tend to come in. So if you have a dynamic server and somebody changes it to static, and then the server is handing out a group of IP addresses, it may hand out a new one that matches yours to someone else. And then you will have conflicting IPs on the network. So you'll have intermittent connectivity issues because you have two IP addresses on the same network with the same IP. You can't have that. So they both can't talk at the same time. So you'll start having intermittent connection issues. This is a tough one to diagnose. So when you find this, you got to find the computer that has the static IP and turn that off so that they can get reissued a new IP from the DHCP.
Can it be more than just the two?
It can, but goodness, I hope that isn't the case. If you get more than two, then it starts to seem like it's on purpose rather than somebody just misclicking a button. So yes, Mark.
Yeah, I had a laptop. I was taking a class at Strayer, and using their network, we set up some things, and I brought it home and ended up with the same IP address as my desktop. So that was kind of fun trying to figure out what was going on.
Did I bring a virus home from school? Yep, I could see that. I could see that. And that one, I mean, and it does happen. It does happen because sometimes people go in there and poke around, not necessarily knowing what they're doing. They set it to static by accident, you know, what have you. And it works fine for about a month, and then all of a sudden it starts causing problems. With a static address would be okay so long as there's not another device on the network with that exact same IP. If you have another device on the network with the same IP, that creates a conflict. They can't talk at the same time. So what you'll see is intermittent network issues. So like if one's trying to search the web, it's okay. But then if the second one tries to log on, then it's not going to work. So say they work in opposite shifts, like one works first shift, one works second shift. So the one person says, you know what, all morning my internet's fine. And then all of a sudden around 1 o'clock in the afternoon, my internet starts acting up. It slows down. It seems like it crashes every now and again and all that stuff, but all morning it's okay. And that's because the person with the static IP has come online around 1 o'clock and now it's causing the issues. That's why it's important to ask, when are these problems occurring? All right. So transition from the internal network into the external network to go out to find out where all the fun stuff is. You have to go through a gateway. And the gateway is essentially a router that allows traffic to go beyond the internal network to go out into the world and talk to other computers. We talked about this earlier. It will translate that private IP address that you've been assigned into a public IP address going out into the internet, because that private one can't be used on the internet, right? So we talked about this network address translation translates a private into a public before sending it out into the internet. Now, that is why when we are putting them together, your hosts or the individual computers are configured with the address of the gateway or default gateway where they go to communicate if they're going to be sending stuff outside the network. And then that router basically says, okay, this is not meant for internal use. Go ahead and send it out to where it needs to go, be it a DNS server, be it to Google or what have you. All right, so how to use IP addresses on the internet itself. So as we talked about earlier, it identifies a computer and a network on which it belongs. So the subnet mask tells us which network. The last part of it tells us which computer on that network. It allows us to utilize fully qualified domain names or FQDN instead of typing in the full IP address. Like we're going to type in www.google.com rather than 8.8.8.8.8. So it makes that transition for us. And the thing that does that for us is called the DNS Server, or Domain Name System. This resolves domain and host names to IP addresses and vice versa. So if I say I want to talk to www.nissanusa.com, it's going to go to the DNS server. DNS server is going to tell me, oh, that IP address is 172.217.15.8. And then at that point, it now can route it across the entire internet to get to where I need to go. But the FQDNs are easy for us to remember. It's easier for us to remember like the name of a website than an entire IP address, especially if we start talking about IP version 6 addresses, which are like 32 characters long. Questions so far with regards to what a DNS does? All right.
When it says it resolves the domain and host names, what that mean? What do you mean resolve?
So kind of like in your phone, in your contacts list where you have mom and it's, 872.555.0101. You're not punching in, like when you tell your phone to call somebody, you're not saying call, 872.555.0101. You're saying call mom. But mom over the airways doesn't mean anything. The phone number is what means something, that 872.555.0101. That's the important piece of information. So what it does is it's translating it from mom to that phone number and then sending that out so it knows where to go.
So resolve is another way to say translate?
To a degree, yes. Yes. So it's able to convert them from one to the other. Yes, Humberto.
Yes, in the previous slide, I was wondering who holds the NAT protocol? Is the router?
Yes, your gateway router has that NAT protocol on it.
Thank
you. Mm-hmm. All right, binary to decimal. We did already do this, but this is just kind of another way to represent it. As we were showing before, it's like it doubles each time. 1, 2, 4, 8, 16, 32, 64, 128. And based on which one of these we turn on, we create our number in an 8-bit system all the way up to 256 or 255 because we count 0 as a number itself. Questions so far? This is when we went over, I think, last week sometime. So are there any questions on how we add with regards to binary? Yes, Rienzi.
Well, my question is not about this slide. About this slide. It was about 2 slides, or the one before, I think, on the FQ, the fully qualified.
Oh, here. FQDN, fully qualified domain name.
Yeah. So do I understand this correctly? Is it just like a matching game, but that domain does?
Yeah, it's basically that IP address matches with that domain name. That's exactly what it is. They marry up. It's like a phone number in a contacts list. So you have mom's phone number. This is her phone number. They match it up. So when the phone number comes in from the internet, it goes through your contacts. Your phone then says mom is calling. And then when it goes the other way, you say call mom, and then it goes, okay, mom's number is blah, 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 and then sends that out over the line. So it's doing that translation for you. It's kind of like your own personal DNS server.
Okay. So the DNS is the database, or they're the I mean, I guess the server just has the database, and then the
yes,
VM.
but there's multiple DNS servers out there.
Okay. Oh, okay.
So it's not just one. I mean, they have them regionally, nationally, globally. I mean, there's a whole bunch of different DNS servers out there, and they do communicate with each other, and they can be hacked, and it does happen from time to time. There's something called DNS poisoning, where they can go in and essentially, like if I go in and I type www.google.com, but they went in there and they changed the IP address for Google to be Yahoo. So I would type in Google and then I would show up on Yahoo's page. Hackers can do much more nefarious things than that. They can send you, like if you type in Wells Fargo for your bank. So you want to go to Wells Fargo, and then they've DNS poisoned it. And they created a website that looks just like Wells Fargo. So you go to their website, and then you type in your sign in and username and password for your bank account. You've now just given them your username and password. There was a guy back in the late 90s that did something like this. He did a DNS poisoning, and he created a sign-in website that looked just like Bank of America. And every time people would sign in with their username and password, it would give them the error message and then redirect them back to the original bank. So what would happen was every time they signed in on his website, he would take a nickel out of their account. Small enough, nobody noticed, because most people don't balance their checkbooks. This went on for months and nobody noticed. It wasn't until finally people started complaining about having to enter their sign-in and password twice every time they went there because of the error message. Only then was he caught. So yes, Luis.
How can you tell when the website is not the actual website, so you can prevent a hacker from taking your bank information?
Sometimes it's very close though. Like
Yeah.
I've seen websites where they would change the 7 to an L, or like it's if you pay attention, you will see it's not the same, but it's so close to the same.
Yeah.
But then if they are elite enough, they can actually take, get in front of the actual website and then do some damage. So
yeah.
But there are instances where it's very, very subtle and you're not paying attention to it. And you click on that. Like, say, for instance, I hit Google and I type in the regions or Wells Fargo or Bank of America. And one of the first pings that pop up, that's the one I normally use to go. Well, what happens if that is not the same? It's another site that's number one. And that's the site that I end up going to, and it looks just like Bank of America, but it's not.
Yeah.
So there's a lot of different ways that they can get you, Luis.
So you look and you might see misspelled words. You might see incorrect grammar. You might see that the color is off. Like the color is like a different hue than what you're used to. I mean, there's various little things. So like if something feels off, don't do it. Go back, make sure you're going to the right site, verify it, move it through. So, but yeah, they can be sneaky. It can be hard to spot these things. All right. Converting binary to decimal. We've all kind of done this one here a little bit, so we should be able to configure it based off of the octet system, 1 all the way up to 128. So is anybody not comfortable with this and needs an example?
I need an example.
Yeah.
All right. So go ahead and draw lines down. And my annotator's all messed up. Let me draw lines down here. Is it really not working? Hold on one second. Like overarching protocols you will use with regards to the type of connection you're making from your computer to the other computer. So we have TCP, which is Transmission Control Protocol, which should sound familiar with TCP IP. And it is a connection-oriented protocol. It creates what's called a three-way handshake, where it's like, hey, I want to communicate with you. Then the other side goes, okay, well, let's communicate. And be like, all right, good, let's talk. And it's all confirmed, and then communication takes place. And it's sending stuff, and it's verifying that what gets sent is what gets received. I'm sending 53 packets to you. Okay, well, I didn't receive packet number 18, 24, and 15. Okay, resending those 3 packets. I'm sending 3 packets to you now because you're missing 3. Boom. Did you get 3 packets? Yes, I got 3 packets. Beautiful. Connection complete. I would like to disconnect. Please do disconnect. Goodbye. This is typically used when you're sending documents, when you're dealing with web browsers and stuff where there's going to be that two-way communication predominantly. Other side of that coin. Other side of that coin is UDP, User Datagram Protocol. Connectionless. You say, hey, I want to watch this movie, and it just starts going, okay, here's the movie, and just starts sending everything to you as quickly as it possibly can. And you got to absorb as much of it as you can. Take it in. If you miss a packet here and there, it's okay. We're just going to keep going with what we can do and just try to get what we can. Kind of like Marvin and I throwing tons of information at you guys all day. You try to grab what you can. We can't stop, go back and fix it. We got to keep moving through. Netflix is a good example of this. You ever been watching a movie or a show and all of a sudden it starts getting pixelated on the screen, but then it cleans itself up? That's UDP in process. Your side missed a few of those packets as they were being sent through, but was able to clean it up and catch up. It's not going to go back and try to fix those packets from 30 seconds ago because you don't care. You've moved on. So it is a best effort transmission style. You try to pull in as much as you can. So TCP, connection oriented, verifies everything that's being sent. UDP doesn't care. Best effort, here's everything. And it just throws it at you and you try to get as much as you can. Voice over IP, phone calls over the internet, that's UDP based. Because it's not going to go back and try to fix something that already happened. You don't care at this point, but every now and you'll hear it where like the voice on the other end of that phone gets a little like robot sounding, something like we hear it in this class. That's where that UDP connection starts to break down a little bit, but eventually, if the bandwidth cleans up a little bit, it can continue forward without much issue. So it's best effort. Questions with regards to those two?
UDP is basically like the pixelation of like Netflix, and you're like, hey man, what's going on with the video quality? It's like literally trying to show like the information. Like
yeah, it's trying to show. It's basically giving you a best effort, showing you exactly what it has received. If it starts, missing big chunks of data, that's where like audio could jump around, the video gets a little pixelated, stuff like that. That's when that stuff starts to occur. Not to be confused with the resolution of your TV. If you get like blur from it moving fast, that's totally different than whether or not you're receiving the data in a timely fashion or without error. So associate UDP with any kind of streaming service or live service or something like that. Now, if you're interacting with websites and stuff like that, doing like Amazon or something, shopping, documents, presentations, stuff like that, then it may be TCP or connection oriented. All right. Network sockets. Software components that we use to connect to a LAN or a WAN, but can also be used to connect with the computer itself. uses programming requests called Application Programming Interface, or API. And you typically would have one endpoint between two computers or two programs connected through a network, not to be confused with a physical socket. IP addresses followed by a colon. When you see like the 4 dots here, and then you have this number right here, that number right there identifies a specific network socket, also known as a port number. Protocols and well-known port numbers. So we talked about TCP, IP, as well as UDP. So both TCP and UDP use port numbers to listen and respond to requests coming inbound from other hosts. And each of these ports are associated with specific protocols for specific things, like our email. Remember, STP. What port is, or excuse me, SMTP. What port is that?
25.
25. So outbound mail going out of the computer, port 25. That's the way it goes. What was IMAP?
143.
So incoming email from IMAP would connect to my computer through port 143. So if I wanted to connect, tap into the email server, I could type in my IP address :143, and that would tell it to go directly to the IMAP port on my computer. Some ports will use just TCP, some will use just UDP, some use both. They don't get heavily into that. It's more of a basic understanding at this point with regards to CompTIA with the utilization of ports. So there are some common protocols and well-known port numbers that the next few slides will kind of go over them. And these are ones that you're going to want to kind of remember with regards to A+. Also, there are some of the most common ports you will be interacting with in the wild as well. All right, well-known port numbers, logical ports. One we talked about yesterday. These are endpoints specified by programs. If I want to communicate with your computer, what protocols do I want to interact with your computer on? The port numbers give a good indication as to which protocols I'm wanting to use. And they are called your well-known ports. First one is one that we talked about yesterday. Is FTP, or File Transfer Protocol. It does basically what it says it does. It transfers files between two computers. But it is a clear text transmission. It is not secure. Now, question is, why does FTP have two ports? It has 20 and 21. And the answer typically comes with your firewalls.
Secure and unsecure?
No, these are both open. But what it is our firewalls have what's called port triggering. You can see this on your routers as well. So say if I send out a request on port 20 asking for a file, it is likely not to send it back on 20. It's going to send it back on 21. So when it passes through the firewall and says, hey, I'm requesting a file port 20, it will send it back on 21. The port will be triggered and say, okay, 21 is available now, and allow that file to come back through 21. Yes, Alan.
So it's like a two-way street for FTP. Like files go one way and they come back on the other port.
Yes.
Okay.
So typically how it works is that you would make the request on 20 and it would respond on 21. That's why it uses two ports. It's one of your oldest protocols. Yes, Humberto.
Yes, I understand that the ports, they belong to the transport layer. So can a router is unable to assign a port number. So which device in the network assign the port numbers?
Well, you would assign that port number. Like you're saying, like your applications would say like, hey, I want to talk to this web server utilizing HTTP protocol. And when you say that, it says, okay, well, HTTP protocol requires port 80. In order for me to talk to them on that port or on that protocol, I need to link to them with this port. So on your application layer, it's basically stating which port it's going to communicate with.
Okay,
We can force that to happen when we say, I want to go to port, you know, I want to go to IP address and then put that colon and port number in. We can make that happen.
Yeah, but that device, in this case, that provides the port number, it has to be the operating system then of the PC or of the server in the other side.
PC.
Not a router, not a...
No, not the router.
Has to be server or PC.
Yeah, basically, yes. So the router, all that's doing is routing traffic for the most part, with the exception of network address translation, where it's kind of flipping the IP addresses. That's the only like funky magic that a router does. Other than that, it doesn't look at the information. It doesn't see what's in there. It's literally just saying, okay, this letter is to Marvin. Here, Marvin. Marvin sends it back. Okay, letter goes to Avery. Here, Avery. So that's basically what a router is doing. It is routing traffic, almost like a traffic cop does. So,
and Pozo, these ports are semi already set up for you. Like a lot of the protocols are already there. So they're kind of already in place. You're not putting these in. You don't have to, because if I'm going to do anything that's SMTP related, then it's going to, we want you to know and acknowledge that that port is 25. If I'm sending a file using this transfer protocol, it's 2021. It's already there. Now, you may get into a place where you have to set stuff up from scratch. That's when you'll need to know where to place these things. But for the most part, a lot of this is kind of already set up, but you need to know what the goal for the class is, for you to know what they are and why they exist. So I don't want you to get lost on the workings of, because a lot of this is already in place for you, but you need to know what they are and how to communicate it and be tested on it.
all right. So FTP, one of the lowest ports, because it is one of the oldest, because the moment we were able to hook up two computers together, what's the first thing we wanted to do? Send a file, talk to each other, see if we can transfer information from one to the other without having to use those funky cards we had to use in the beginning, or 50 floppy disks to get one image, you know, stuff like that. So we want to be able to transfer files. 2021 file transfer protocol. Next up on the docket is SSH, secure shell, used to pass login information to a remote computer and control that computer over the network. And it does have some encryption associated with it. That's why it is secure. So secure shell. After that, we have Telnet, which allows you to control a computer or server remotely off of port 23. Although you are transmitting in clear text, there is no encryption involved with this. So it's one of those things where do not pass secure or confidential information over Telnet unless other protocols are taken into consideration or taken in place. So Telnet 23. And then the very familiar SMTP, simple mail transfer protocol, or send mail to people, used to send email messages off 25. And then we have our domain name system, DNS. We just talked about that one today. Translates the FQDNs into IP addresses and back again. And that is off port 53. I will pause here for a moment, let everybody take out whatever information they wish to take. And then we will move on to the next slide, whether you want to get a screen capture, or what have you. Give me a thumbs up when we're ready to move on to the next slide. All right, good deal. Next, HTTP, Hypertext Transfer Protocol. This is what governs the way web servers and us, the clients, interact with them. These are the protocols we use. This is off port 80, one of the most common ports you will come across. Next, we get our POP3 and our Imap. We are very familiar with these because they come up quite regularly. Don't worry, we'll start adding in the other ports too. So, receiving mail, POP3 and Imap. POP3 is not synchronized, and Imap is a synchronized system. POP stands for Post Office Protocol. It is an older system. And then you have Imap, which is Internet Message Access Protocol. Then, as when we interact with websites, sometimes we pass sensitive information like credit cards, addresses, things of that nature. We don't want to do that out in the open. So we have HTTPS, S standing for secure. Hypertext Transfer Protocol Secure. This encrypts and decrypts the data that is being sent across the network. When you look up in your browser and you see that little padlock and that lock is closed, that means you're operating on an HTTPS. If that lock is open, that means you're on HTTP and not secure. So that is the meaning of that little padlock in your web address in the top. So when that lock is closed, you're secure, you're on HTTPS, communicating over port 443.
I was wondering, that game you just gave us had a closed lock.
Yep, it's a secure site. All right. Most are, you are correct. Most are now. RDP, or Remote Desktop Protocol, heavily used by IT professionals everywhere who are working with Windows systems. 3389 RDP, used for you to be able to remote in and assist other clients on their own systems. It has to be turned on and available on their system, but will allow you to link in and help them out from that point. And this is the port you would be connecting with them. And then we have AFP, or Apple Filing Protocol. Two guesses who created it. And it is a proprietary resource sharing protocol used by Apple, although it is not used very much now. They have other things in place. Questions so far on these? Yes, Humberto.
Yes, so the RDP protocol will work only to Windows operating systems.
It is, yes, it is a Windows remote access system.
And if it is a Linux, is there another port or another protocol that you can use?
Yes, there is. Absolutely. Although that is a fun exercise to learn how to remote in on a Linux. And I think there's a test out lab for that. Yes, you do need to know the numbers. You need to know which protocols and the numbers associated with each of them. So remember what I told you when I came in the morning, I wrote down all my port numbers. These are the numbers I was speaking of. Now, do a little mind reading here. Do Marvin and I have a mnemonic to help us remember the ports? I don't know, Marvin, did we take the time to make one of those up?
You know what? Yeah, we did.
Okay. Okay. Good deal.
It's coming up, right?
It's coming up.
Yeah, it's in the slide.
All right.
But
Here
nothing
they are
beats
kind
you
of
doing
listed
it
again.
yourself, bro.
Do what?
I said nothing beats you figuring out how to remember it yourself because you
I'm
put
terrible at coming up
put
with
your sauce
mnemonics,
on
man.
it.
I'd rather just use other people's. I don't care how crazy it is. I'm not good at coming up with them myself.
Okay,
I'll
got
be
you.
honest about that. All right, so here, do what?
That's I got you, sir.
I know, man. You come up with this stuff all the time. It's great. So TCP protocols, common ones you use, the DHCP, which we know that's our internet protocol, gives us our IP address. We have the DNS, which is our translates IP addresses to FQDNs. We got LDAP. LDAP. This is a good one to remember. Lightweight Directory Access Protocol. It's kind of like a little phone book or directory when you're dealing with a company. So like if you go to a company and you're like, well, who's the email for, the head of HR? They may have an LDAP protocol here that has a listing of all the people that work for the company, their contact information, how you can get a hold of them. So it's not real detailed. It's not going to give you everything that they've got going on in the company. That's why it is lightweight. It does not have a ton of information, but it does have some key information in there for you. So lightweight directory, letting you know it's kind of like a phone book, access protocol. Simple network management protocol. If you are monitoring people's networks and you're dealing with security and or a network engineer working on the, working for the networks and stuff like that, SNMP is going to be your best friend. This is how you communicate with a lot of your internet devices, how you remote in, talk to them, set up standard procedures, stuff like that. You won't use it much before CompTIA, but if you get into Network Plus, SNMP becomes very important.
What happened to the S?
User error on that one.
Names and faces have been changed to protect the guilty.
Yeah.
Not sure why. All right. SMB, server message block, Microsoft protocol used for reading and writing files and request services from server programs themselves. SSH, secure shell, used to pass login information to a remote computer and to control that remote computer over a network. And then we have SFTP, which is like your file transfer protocol, but they threw that fun S on the front for secure. So this would be a secure way to transfer files between two computers. Uh-oh, we've gotten into optional slides.
Bonus.
All right, here is a good one to have a screenshot of because it tells you what protocols are utilized on what layers of the OSI model. So I would highly recommend taking a screenshot of this. Also, it shows you, so you have your upper layer data or your where the datagrams are called. So you have your upper layer data. And then once it gets down to layer 4, it's called a segment. Layer 3, it becomes a packet. Then it becomes a frame on layer 2, and then bits. It's sent out as ones and zeros on the physical layer. Questions so far? Let me know when you got a screenshot of this and you're good to go. And then with the Google one, you can tell these top 3 layers here were combined to create the application layer. And that's why their model only has 5. Here's a bunch of public class A addresses. There will be a quiz tomorrow on this, so
Get a
might
good
wanna-
glimpse.
get a good glimpse at it,
Really, just to show you how big these.
Yeah, it's just to show you how big the networks are.
That's all.
We're not gonna be that mean.
Got GE up there. You got IBM.
Yep.
Defense, Army, all of those guys. IANA, which is the Internet Assigned Numbers Authority. Prudential. So
just kind of give you a feel for the fact, like all of these, you should really recognize what they are because of how big they are.
Yeah.
Virtual local area networks. We'll talk about this a little more when we start getting into internet devices and servers and stuff like that. We talked about it a little bit where I was saying like they could, section off little ports within the switch and create virtual LANs within your network. We will talk about this a little bit more probably on Friday, I believe. So it just kind of makes your configuring your networks easier. You don't have to physically relocate people. You can just reassign how the ports are set up. And here's a good shot of what a virtual network would look like. So you have like your virtual 1, virtual 2, virtual 3. They're all on the same switch, but you have different ports on each switch dedicated to each network. But again, we'll talk about this a little bit more on Thursday or Friday.
VPN, my favorite. So find yourself having to do some work away from your organization. Have to take some work home, and you also need to connect back to your organization's network. We want to do this as safe and as secure as possible. Ergo, virtual private network, aka VPN. VPN has several uses, but for organizational setting, enterprise setting, it's designed to create, if you look at it, a tunnel from your PC, be it work or home PC, to your network at the job, at the organization. So you find it, so you use the internet as a means of traveling, but you block out any nefarious individuals that could potentially want to tag along on that ride to the network for your company. Now, I've seen where it can be an issue to get this set up, but the main thing is knowing what information needs to go where and what type of applications that are already in place to assist with the setting it up. My wife has to use it to get into charts and stuff. So when she can't get to her network, I always, ask her, when last time you like fully logged off or turned the computer off? Like there are certain stop guards and little rails to help keep you, because I keep my computer on, but I'm not attached to a corporate entity that has private or proprietary information. So once she shut it down, turn it back on, choose the appropriate browser, because that helps. And we're back off to the races. But that's the work organization reason. I think in previous technical sessions or just offline, we talked about how if Rienzi is on the West Coast, she's from Virginia, and she's going to visit family that's not the West Coast, California. And she's going to visit family on the East Coast of Virginia, but she wanted to catch a local showing of whatever that's happening back home. You could potentially use a VPN and allow yourself to create a at-home IP address so your computer or device will be able to view local because it's recognized as being away from the city or state that it's in. That's VPN. Any questions about VPN? I saw what you just said, Justin. You want to be able to have ways to protect yourself. Has anyone received a letter or some type of email or anything from your internet provider talking about, hey, I saw you watching this movie that's at the movies? You can't do that. So don't do that again or you're gonna get in trouble. Has anybody ever got one of those letters?
So you're telling me that you can't watch a movie at the movies?
Not if you're not going through the proper channels. This was before HBO Max. This was many moons ago when movies would pop up at the movies and somehow
Pre-2020.
Yeah.
Or, the movie's been released in Europe and you're watching it in your living room.
You watch it, yeah. So and how do you think they know? They
They
company,
monitor what you're doing.
Yeah, the company is watching. The company that made the movie is watching, and they're like, "Hey, our movies being shown through your internet, through your provision of internet, and I can even get you to an IP address, and because they got little things they can attach to the movies to help with that. So your your provider is gonna be like, "Hey, man, Luis, you got to stop doing that." They'll hit you on the hand. If you do it again, you'll get in trouble. VPNs can help with that. But
we would never.
Yeah, of course not.
We would never encourage.
That was an example of what not to do. That's exactly how I would phrase that. Any questions about VPN? Very, very good for its uses and necessity, especially for people working remotely and having to get back in connection with their network from home, away, remotely. So that's what it
makes the system think that you are there, essentially.
To allow you access, to grant you access. That's exactly right. All right, here we go. We told you we had a mnemonic for you. And one of those are, for safe technicians, simple deeds help put immature hackers at rest. That will allow you to line up those well-known ports from smallest number to biggest number in order to try to figure out if you have all of them written down. Like, say, for instance, I get on a test and I'm at pop 3 and I can't think about it being 110, but if I do this, help put immature, I know it would fall within 80 and 143 if I had those. So I'm like, what's that number? Oh, it's 110 because I got them lined up. So that's why we have these. And it also gives you an opportunity to, like, for save technician. Now I'm thinking about what letter, that's the first letter of each one of my ports. I got ways to try to figure out how to retain it. Y'all like that one? I think we got another one, but this one's pretty cool.
I think this is the only one we have for that. I had the 2 for printers, but only
this one. 2 for printers. That's what it was.
So, yeah. So what I would do is when I would come in the morning, I would write the for safe technician, simply, and then I would try to write down all my ports and see if I could get all my ports correctly.
You can't quit, but you can step away there, Pozo. Get on that plane, man. Have a good day. We'll see you. Man said, can you quit? No, no quitting. No. Step away, though.
Yeah. You can leave for the day. It's fine.
Yeah.
All right.
All right. We're gonna move.
Any questions?
Did you guys get it? Everybody jot it down or at least got okay. Okay.
I don't know, Jimmy. The last person that said they needed to take their dog to the vet never came back to class.
Yeah, man. So we're very weary of that. So please just come back. You and the dog, come back, okay? All right, that's good. That's noted.
All right. So now
For real
we
time.
should be able to explain the purpose and role of TCP/IP in the internet or private network. Explain the characteristics and properties of TCP/IP addresses. You probably know way more about it now than we ever thought we wanted to know. And explain common TCP and UDP ports, protocols, and their purposes.